aircraft materials, processes, and hardware, rivets, screws, and safetying methods. The learners will be able to identify the different types of rivets, identify the different types of screws, and describe the different types of safetying processes. Rivets are used in aircraft construction to fasten sheets of metal together. Two major categories of rivets are the solid shank rivet, which require access to both sides of the rivet, one for the bucking bar to make a shop head and the other one for the rivet gun. And then the blind rivet, which you only need access to one side of the rivet and do not require a bucking bar. Standard rivets sold in common hardware stores are not suitable substitutes for rivets manufactured for use in aircraft construction. Solid shank type rivets are identified by the material they're made of, the head type, and their temper condition. The majority used in aircraft construction are made of aluminum alloy. Head types are round head, flat head, brazier head, universal head, and countersunk head. The two most common are going to be the universal head and the countersunk head. Markings on the head of the rivet are used to identify the alloy designation and the strength of the rivets. The strength and temper conditions of a rivet are identified by the digits and letters. 2017 and 2024 are often referred to as the D or the double D rivets. They're also referred to as icebox rivets. It must be heat treated to be annealed and then kept in a frozen state until driven. Once they're driven, they'll reach full strength after about 4 days. Identification markings on their heads are used to classify these rivets. The most common type of rivet used are the 426, which is a 100-degree countersunk, and the 470, which is a universal head. Blind rivets can be divided into two classifications, structural and non-structural, or non-structural and mechanical lock. The non-structural blind rivets are going to include self-plugging rivets. They have a friction lock, and then they have pull-through rivets. The problem with the non-structural rivet is there's nothing there to hold the pin. Once you pull it and snap it off, that pin over time can vibrate loose, which is going to reduce the strength of the rivet. The mechanical lock rivet has a device in there that's going to hold that pin in that rivet when you pull it through, and that's going to maintain the strength of the rivet. So the mechanical lock type rivets would be a bulbed cherry lock, a pull-through blind, a wire draw cherry lock, and a Huck mechanical lock rivet. Pinned rivets are special rivets but not considered blind rivets. There are also special fasteners that can be used in aircraft construction in place of bolts, taper locks, high teague, captive, turn lock, and Zeus fasteners. Here you'll see a rivet chart, and you'll look at the material. It'll tell you what the material is made of: 1100, 2117T, 2017T. It tells you what you would look for, the markings on the head. It tells you, gives us an AN code, and then it tells us, it just gives you an overall, the shear strength, the bearing strength, things of this nature. And here's another chart with some more rivet heads. Tells you again the markings you're going to see on the head, and then just exactly what the rivet's going to be used for, the strength and things of this nature. Screws used in aircraft construction are classified into one of three groups: structural, machine, and self-tapping. Cam locks and airlock fasteners, along with self-tapping and drive screws, can be used in aircraft construction. Nut plates are used when access to the back of the screw or the bolt is not practical. Nut plates can be riveted in place, or they could be rivetless. They could be squeezed in. Control cables and terminals. Cables are going to be used to control emergency landing gear extension. Some of your smaller aircraft and your older aircraft use cables to control the flight controls. Cable designations and flexibility are based on the number of strands in the wire. So if we look at the two wires in the picture here, we have a 7 on the bottom, which means there's 7 strands of wire in each individual strand, and then there's 7 strands of 7, so you can see. And then in the top one, there's 19 wires in each strand, and there's 7 strands in that one. So the wires are a little bit smaller, makes it a little more flexible. The 7 sevens are the same thing, 7 strands and 7 wires to each strand. Cables can be equipped with different types of swag on ends or swedged on edge, depending on what we're using them for. And then when we use them in flight control systems and things of this nature, we're going to use a turnbuckle to connect one cable to another, and then we can use the turnbuckle to adjust the tension of the flight control cable or the cable to make sure that it's within specifications. Safetying is a process used to ensure all aircraft hardware, nuts, bolts, screws, etc., do not come loose because of vibration or movement in flight. Methods commonly used in aircraft construction and maintenance for safetying are going to include safety wire, cotter pins, tapered and flathead cotter pins, roll pins, lock washers, snap rings, special nuts, jam nuts, lock nuts. Several methods we're going to use to safety items, but realize everything we install on an airplane should have some type of safety method so it doesn't vibrate loose. Loose hardware in airplanes is a bad thing, could cause FAA, get jammed in flight controls, things of this nature. Here's some examples of some safety wire. Examples 1, we have a bolt safety to another bolt. Notice the safety wire is causing each bolt to tighten each other up, so if the top bolt starts to loosen up or go counterclockwise, the bottom nut is actually going to get tighter. This safety wire should have, per a typical 32,000 safety wire, about 8 turns per inch. As we get into the lab projects, we'll get into some specifics on how to safety. Notice number 2, we've got a bolt that's actually safety wired to what appears to be a nut on a stud. Number 3, we've got 3 bolts that we've actually safety wired together. That's typically about the maximum you're going to want to safety wire is 3 bolts. I do believe you're not going to see anything that has a twisted wire like that that's safety wired more than 3 bolts together. And notice each bolt, if I cut either one, the top or the lower safety wire, they're still going to be causing each of the other 2 that are still attached to tighten each other. Number 4 is 2 nuts that are on a stud. So the safety wire is going through, it's keeping the stud from turning, but at the same time it's keeping the nut from backing off. So you can look again at the different types. Number 8 is an interesting one. Those are several screws that are in close proximity. That's a single strand of wire. And each strand of wire, as it passes through the screw head, is going to be causing that screw to be tighter. Not much to say here. I think we've covered every one of these. Number 6 looks like a drain plug or a screw that's just safety wired to a piece of hardware. So in summary, rivets are used in aircraft construction to fasten pieces of sheet metal together. Rivets for aircraft construction are specifically made to standards. So we're not going to go to a common hardware store and actually pick up rivets off the shelf and use them there. You want to use aircraft specific rivets. Solid shank rivets and blind rivets are used in aircraft construction. They're identified by the material, by the type and the shape of the head, and their temper condition. Screws and nut plates are used in aircraft construction. Screws can be structural, machine, or self-tapping. And nut plates can be rivet or rivetless. And a nut plate is going to be used where we don't have access to put a nut in the back, typically used for panels that are coming on and off on a very normal basis. Nut plates that are installed can also be self-locking. Safetying ensures that all aircraft hardware does not become loose in flight due to vibrations or movement and reduces the potential for FAA to get jammed in flight controls and things of this nature.